Okay, so let's get started. So don't forget, guys, that Benjamin is here, so he'll be able to answer your questions. And I believe that this is the first problem we did not do last time. So welcome to part 3 of geometry, and let's go ahead and start. The two circles pictured have the same center C. Chord AD is tangent to the inner circle at B, AC is 10, and chord AD has length 16. What is the area between the two circles? Okay, so a lot of people have answers, so let's go ahead and start. Okay, so they tell us that AC is 10, so this length here is 10, and AD has length 16, which means that half of it, which is AB, has a length of 8. Now, since this is a right triangle, we can easily tell that BC is going to be equal to 6, since it makes a 3, 4, 5 right triangle. And if BC is 6, 6 is the radius of the inner circle, then that means 10 minus 6 equals 4 is the outside distance. So if I redraw that, that means that this length is 6 and this length is 4. So therefore, if we subtract the area of the two circles, then what we get is pi times r squared, pi times 10 squared, minus pi times 6 squared is going to be 64 pi, which is C. Okay, so moving on to the next question. In the given figure, hexagon ABCDEF is equiangular. ABJI and FEHG are squares with areas 18 and 32 respectively. Triangle JBK is equilateral, and FE is equal to BC. What is the area of triangle KBC? Okay, so let's get started. So they tell us that FE is equal to BC. Now, since they tell us that FEHG is a square, that means FE is equal to the square root of 32. So this is the square root of 32. Now they also tell us that IJBA is a square and JBK is equilateral. So since the area is 18, then that means the side length is square root of 18, which also means that BK is the square root of 18. So BC is also root 32 since it's equal to FE. So now we have to figure out what type of triangle BKC is. So let's try to look for angle KBC. So they tell us that the hexagon is equiangular, which means every single angle in the hexagon is the same. So all the angles in the hexagon added together is 180 times 6 minus 2. So does anybody have any questions as to how I got that? So essentially there's a formula that says that the sum of the angles in a polygon with n sides is 180 times n minus 2. So if we go back to 180 times 6 minus 2, and we divide by 6 for each angle of the hexagon, then what will that give us? Well, that will give us 30 times 4, which is equal to 120 degrees. So now we know that angle ABC is 120 degrees. So angle JBA is obviously 90 degrees, and they tell us that JBK is 60 degrees. So to find out what angle KBC is, we subtract all of those angles from 360 degrees. So 360 minus 120 minus 90 minus 60 will give us 90 degrees, I believe, which means that angle KBC is a right angle. So now this becomes kind of easy because we can immediately do 1/2 base times height. So 1/2 times root 18 times root 32 is the area of triangle KBC, and I believe that comes out to 12, which is C. Okay, moving right along. Okay, angle ABC of triangle ABC is a right angle. The sides of triangle ABC are the diameters of semicircles as shown. The area of the semicircle on AB equals 8 pi, and the arc of the semicircle on AC has length 8.5 pi. What is the radius of the semicircle on BC? Someone asked if we're planning on launching any new math courses. Not for the moment. We do have a few more courses that we have planned that are going to start in September, but none of them are specific to math. You'll get notifications on the newsletter and social media when we launch the other courses, but right now we don't have any immediate plans for math courses. That might change though, so just keep an eye out for that. Okay, so let's get started. So they tell us that the area of semicircle on AB is 8 pi. So that means that this area is 8 pi. So since that's only half the circle, that means the full circle would be 16 pi. And since the area of the circle is pi r squared, then that tells us that the radius is 4. Which means that the diameter AB is 8. Okay, so next they tell us the arc of the semicircle on AC, which is this length, has length 8.5 pi, which means that the whole entire circle would have a circumference of that times 2, which is 17 pi. So since the circumference of a circle is given by the formula pi times the diameter, that means that the diameter of this semicircle must be 17. So this here is 17. So since this is a right triangle, if you use the Pythagorean theorem, you'll get that this length is 15, which means that half of it, or the radius, will be 7.5, which is B. Okay, so moving on. In the figure shown, US and UT are line segments, each of length 2, and the measure of angle TUS is 60 degrees. Arcs TR and SR are each 1/6 of a circle with radius 2. What is the area of the region shown? Okay, so they tell us that this length right here is 2, and this length right here is 2. Someone asked, is the M in angle TUS supposed to be there? Yes, because this M here means measure. So the measure of angle TUS is 60 degrees. So it's technically incorrect to write angle TUS equals 60 degrees because you need to put the M in front of it to denote that the measurement of angle TUS is 60. So that's why the M is there. A lot of times people will just drop the M though, so it's not really that much needed unless you're writing like a really formal math proof or something. Okay, so let's just try to complete arcs RS and RT and see what we get. So if I complete it, I'll get a circle. This is a horribly drawn circle. And we get another horribly drawn circle. Okay, that was too bad. There we go. Okay, so the centers of those circles are here and here. And because they tell us that the arcs have radius 2, 2, that means that, okay, we're just gonna ignore that. Okay, so that tells us that if we connect the centers to US and UT, we'll get this completed triangle. So this triangle is actually an equilateral triangle with side length of 4, which means that technically the total area of it would be 4 squared root 3 divided by 4, I believe. Is that the correct formula? Okay, sure, why not? Okay, so that would be the area of the equilateral triangle. But the shape that they're asking for is the equilateral triangle minus these two circular sectors. So we're going to have to subtract those two. So each of those is 1/6 of their respective circles, which means that it would be 1/6 times pi r squared, and r is 2. And don't forget that we have two sectors, so let's multiply by 2 again. And we'll get 4 pi over 3. So we take the area of the equilateral triangle, we minus the red shaded sectors to get the area of the region shown, and our answer turns out to be B. Okay, so someone asked, are we going to get to algebra today? It depends. Last time you guys voted that you wanted to keep doing geometry because we didn't finish all the questions, so I'm not sure if we'll get to algebra. Because we still have, I think, a decent number of questions left. Okay, so moving on. A circle of radius 2 is cut into 4 congruent arcs. The 4 arcs are joined to form the star figure shown. What is the ratio of the area of the star figure to the area of the original circle? Okay, so let's start here. So a circle with radius 2 pi r squared obviously has an area of 4 pi. So now we need to figure out the star figure. So an easy way to do that would be to notice that we can draw a box around it. And it's kind of a bad box, but if you draw a box around it, you'll notice that the area of the center is basically the area of the entire square minus these 4 quarter circles. And 4 quarter circles make up one entire circle. So the area of the square is, this is 4 by 4, which means that it's 16 and then minus the area of one entire circle with radius 2. So that would give 4 pi. So that's the area of the star figure. And they're asking for the ratio of that divided by the original circle, which is 4 pi. And simplifying that gives you A. Okay, moving on. In the right triangle ABC, AC is equal to 12, BC is equal to 13, not 13, 5, and angle C is a right angle. A semicircle is inscribed in the triangle as shown. What is the radius of the semicircle? Okay, someone's asking for a hint, so sure. So imagine that you're drawing the center of the semicircle, which is going to be somewhere there. And let's set the radius equal to r. So if we drop the altitude here to the tangent point, that's going to be a right angle. And this length is also going to be r. So there's a hint for you. So basically you can find a lot of things in terms of r. So if AC is 12, then that means A to the center is going to be 12 minus r. So try to set up an equation in terms of r and solve. Square root of 24 times 6 minus r. Did you find what that was equal to? Because you need like two sides of an equation in order to solve it. I'm assuming by two tangents theorem, you mean that a point connected to tangent points of a circle, those tangent lengths are always going to be equal. Is that what you mean by two tangents theorem? If so, then yeah, you could use that to solve this. Yeah, so if you like use two tangent theorem, then that means that this length here is also 5. And the hypotenuse of AB is equal to 13, so 13 minus 5 is 8, so this would be 8. And then you could set up like Pythagorean theorem with these three numbers and solve it. Yeah, so let's just solve it. So the way I just explained was one way. So if we do that, then we get that r squared plus 8 squared is equal to 12 minus r squared. So if you just solve that quadratic equation, which is not really quadratic because the r squares cancel out, then you'll be able to solve. Another way you can do it is you can look for similar triangles. So for example, this triangle here and this triangle here are similar by AA because they both share angle BAC and one right angle. So if you try to use similar triangles and set ratios equal, then you'll get that r divided by 5 is equal to 12 minus r divided by 13. So both of those are valid methods, and both of those will give you r equals d, which is 10 over 3. Okay, so let us move on. What is the area of the shaded pinwheel shown in the 5 by 5 grid? Okay, so let's try taking the area of the whole entire square and subtracting off the white parts. So the area of the whole thing is 25. And let's subtract off these 4 corner squares, which each have area 1. So subtract 4. And now we have to subtract each of these bigger triangles. So there's 4 of them. And the area of each one is 1/2 times the base, which is 3, times the height, which is 2.5, which is 5 over 2. And if you calculate this, the 4 cancels out with 2 1/2s. And you'll get that 21 minus 15 is equal to 6, which is B. Okay, so moving onwards. Squares ABCD, EFGH, and GHIJ are equal in area. Points C and D are the midpoints of sides IH and HE respectively. What is the ratio of the area? Oh, did we already do this? Yeah, someone says we already did this. So yeah, I'm gonna skip this problem then if that's true. And if we did already do this, that means you can probably watch the solution on YouTube. So you guys can go do that. Okay. Wait, people are saying we did this problem too? Okay, so I'm just gonna, let's just start off with this problem. If we didn't do this. Oh wait, no, someone's saying we did this again. Okay, honestly, I don't remember, so how about we do this? So whoever wants, does anyone want to see the solution for this? Okay, people are saying they want to see the solution for this, so let's just do it. Rectangle DEFA below is a 3 by 4 rectangle with DC is equal to CB is equal to BA. What is the area of the bat wings shaded area? Okay, so to find this area, let's just subtract all the white areas again. So we know that this bottom length here is 3, this is 4. So what you can do is notice that BCEF is a trapezoid, which means its area is 1/2 times the bases added together, which is 4, times the height, which is also 4. And you'll be able to get 8. Okay, so now what we want to do is we want to subtract the white parts. So if you notice here, then you'll see that triangles, let's call this middle one G. I don't think G is used, yes, right? So the middle point is G. You'll see that triangles BCG and EFG are similar. And that means that since EF is 3 times of BC, that means all aspects of triangle GEF are 3 times triangle BCG. So the more important thing here, okay, that's a bad line. Okay, so the more important thing here is that the bottom height is going to be triple the top height. So basically, Since the whole entire height must be 4, that means the bottom height must be 3, and the top height must be 1. So if we take 8 and subtract the 2 white triangles, 1/2 times a base of 3 times the height of 3, minus 1/2 times a base of 1 times the height of 1. So if you do this, then you'll get C, which is 3. Okay, so moving on. Margie's winning art design is shown. The smallest circle has radius 2 inches, with each successive circle's radius increasing by 2 inches. Approximately what % of the design is black? Okay, so notice that the entire design, which is going to be our denominator, is just the area of the biggest circle. So let's just start small. So the smallest circle, which is here, has a radius of 2 inches. And each successive circle's radius is increased by 2 inches. So that means this circle's radius is 4, this circle's radius is 6, this circle's is 8, and then 10, and then 12. So the biggest circle has a radius of 12, which means that its area is pi times 12 squared. So now let's just count the black parts. So the smallest black part is a circle with radius 2, so pi times 2 squared. And next, this black part here, which I'm highlighting in yellow, is a black circle of radius 6 minus a white circle of radius 4. So we'll be able to get pi times 6 squared minus pi times 4 squared. And finally, the third black section is, which I'm highlighting in yellow here again, is a black circle of radius 10 minus a white circle of radius 8. So then we'll get pi times 10 squared minus pi times 8 squared. So that's the entire numerator. So if you calculate this fraction and convert it to a percentage, then you should get A, which is 42. Actually, you know what? Let me just calculate it quickly. So we can cancel out all the pi's actually. So goodbye pi's. Numerator will get 4 plus 36 minus 16 plus 100 minus 64 over 12 squared. Okay, so if we start pairing things up, we'll get 100 plus 40 minus 80 over 12 squared. So 100 plus 40 minus 80 is going to be 60. And 60 over 12 squared, which is 144. If you cancel some things out, you can cancel a 4. And from there you can cancel, let's say, a 3. And you'll get 5 over 12. And that number is approximately 42%. Okay, so moving on. Okay, someone says wait. Oh, you want me to do, okay, sure. So to convert 5 over 12 to a percentage, then we kind of have to increase 12 to 100. So we'll have to multiply both the numerator and denominator by 100 over 12. So let me just erase some stuff up here. Okay, so 5 times 100 over 12 over 12 times 100 over 12 equals 100 over 12 you can simplify to 50 over 6, which you can again simplify to 25 over 3, which means you'll get 125 over 3 divided by, there should be a 1 here, divided by 100. And so that's basically what the percentage is written as. So if you just calculate 125 over 3, then that's your answer. Okay, so moving on. A circle with radius 1 is inscribed in a square and circumscribed about another square, as shown. Which fraction is closest to the ratio of the circle's shaded area to the area between the two squares? So the circle's shaded area is this area right here. So it's the 4 gray parts. And then the area between the two squares is all of the shaded parts, the dark gray plus the light gray. Okay, so the circle's shaded area is the total area of the circle minus the white square. So our center is here, and if we connect the center to the corners, okay, that's a very bad line. then because the circle has radius 1, each of these is 1. So that means the side length of the square using the Pythagorean theorem is square root of 2. So the area of the circle is pi minus square root of 2 squared, which is just 2. And this gives you the light gray shaded area. So now for all of the shaded areas, that's just going to be the big square minus the small square. So big square has a side length of 2, which gives you an area of 4, minus small square, which has an area of 2, and that gives you 2. So the total ratio is going to be pi minus 2 divided by 2. So if you approximate this fraction, then you should get an answer of 1/2. Okay, moving on. Hang on. 1-inch squares are cut from the corners of this 5-inch square. What is the area in square inches of the largest square that can be fitted into the remaining space? So this is somewhat of a trick question because you can actually fit a bigger square in it than you think. Like, for example, let me just draw an example. What if I had a square that looked like this? Okay, that's kind of bad. Let me just that's kind of a bad picture, but okay, not the best square, but okay, what if I had a square that looked like that, let's say? Right, so this is much bigger than like if you just try to fit it in a square that ran horizontally and vertically. This class is going to end at 7 o'clock Eastern time, so in a few minutes. This will probably be our last problem. Someone asked about an AMC 10 problem series. We might do that in the future, and we'll let you know if we decide to. There's actually a class interest form on our website that you can fill out to suggest new classes. After this problem, we have actually 4 more problems. So we unfortunately will not have the time to go over those, so you can try those out at home. But next week, we'll be moving on to algebra. So to get to the website, just type in alphademic.org. So that's our website address. And you can sign up for our newsletter there, and all the classes will be available there. So any other answers for this problem? Someone asked if we can go overtime. Is that fine with other people? So we can finish the 4 remaining geometry problems. Okay, so let's start with this problem. So the first thing we can do is I drew a sample red square here that is much bigger than an area of 9, which a lot of you said. So let's just try to set some variables. Let's just set this length, shorter length, equal to x. So by symmetry, that means that this shorter length would be x, this shorter length would be x, and this shorter length would be x. So it would be kind of symmetric all around the whole thing. So since the square has a side length of 5 and the corner squares have side lengths of 1, that means that in the center, this other length here is 3 minus x. All around. Okay, so to get the area of the square, we can try subtracting off the white area. So to get the largest square possible, we have to get as close to the boundaries of this shape as possible, which means that the side lengths of our square have to be touching the corner squares. So we have to have touching points here, 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 and here. The reason why it's 3 minus x is because they tell us that this length is 1, this length is 1, and the total length is 5, which means that the middle area, the middle length here must be 3. Okay, so let's just take our 5-inch square, which has an area of 25, subtract off Subtract off these yellow shapes, and there are 4 of them. So, okay, so each of these yellow shapes is going to have an area of 1/2 times base times height. And base times height is going to be 3x minus 3 minus x plus 1 times x plus 1. So basically, since they're asking us for the maximum and the largest square, we have to maximize this expression. So if we simplify a bit, we'll get 25 minus 2 times 4 minus x times x plus 1, or 25 minus 2. No remote control of the screen. Okay, so 25 minus 2 times 4x plus 4 minus x squared minus x. Okay, so if we expand this whole thing out, we'll get 2x squared minus 6x plus 17, I believe. Yeah, that's correct. So they're asking us for the maximum possible value of this quadratic. So let's just clear this up here. Okay, so to get the maximum possible value, there's a few things you can do. You can try completing the square. Right, so hang on, let me decline this remote control thing. Okay, so someone asked if we can just finish this problem and not do the rest. What do you guys think? Okay, how about this? For the last 4 problems, let's try to vote on the ones that we should do. So let's say we vote on 2 of them. I mean, you guys can technically leave whenever you want. I'm not like forcing you to stay or anything. Okay, so let's just continue with this problem. So we have a quadratic here, and what we want to do is we want to maximize it. So you could try completing the square. You could try a few other ways. Let's just try completing the square. The calculations will probably be a bit bad, so I'm not gonna actually like manually compute them. But if we factor out the 2, we should get 2 times x minus, and then what number would go here? Probably 3/2. Yeah, you know what? This problem is kind of turning out to be a bad problem. So in the interest of time, let's just, how many minutes are overtime are we? 7? Okay, so for the interest of time, let's just quickly move on to the next ones, and I'll let you guys vote on which ones we can do. we'll probably only have time for maybe one more problem. So what do you guys think of this one? I should probably show you guys all the problems. Okay, so this one, this one, this one, or this one. The answer to the previous problem should have been C, which is 15. Okay, more people are saying this one, so let's just quickly do this one in the interest of time. So like very quickly do this one. Hang on. Okay, so I'm just gonna directly do it since we don't have that much time. So we have our coordinate axes. Y equals 5 is going to be this line up here. And this distance here is 5. Y equals 1 plus x is going to have a slope of 1 and a y-intercept of 1. And y equals 1 minus x has the same y-intercept but a negative slope. So they're asking for the area of this triangle. So keep in mind that this distance is 1, this distance is 4. Okay, so to get the area of that triangle, we technically already know the height, so we can just try to find this length below here. So let's just try to find this point, for example. So that happens when we solve the equations y equals 5 and y equals 1 plus x. So if we solve that, we'll get x is equal to 4 and y is equal to 5. And if we solve the other points, y equals 5 and y equals 1 minus x, then we'll get that x is equal to negative 4 and y is equal to 5. So then that means this entire base here has a length of 8. So if the base is 8 and the height is 4, then the area is going to be 1/2 times 4 times 8, which is going to be 16. Okay, so that was the last problem. We're running out of time, so I'm just going to quickly end this meeting. Have a good week, everyone, and next week we're going to do algebra.